Last class we discussed increasing function, decreasing function. For a linear function, how can we check whether the function is increasing or strictly increasing, decreasing or strictly decreasing? Linear function. Let us take f of x equal to 2x plus 1. Let us take x1 less than x2. Then we have to check whether f of x1 less than f of x2 or f of x1 greater than f of x2. According to that, we can say it's an increasing or decreasing function. So we can start from x1 less than x2. Now multiply both sides with 2. Then it becomes 2x1 less than 2x2. Now add 1 on both sides. Then it becomes 2x1 plus 1 less than 2x2 plus 1. Now what is 2x1 plus 1? That is f of x1. If you replace x by x1, then you will get f of x1 is equal to 2x1 plus 1. Now f of x2 means it is 2x2 plus 1. Now what we got? F of x1 is less than f of x2. So x1 less than x2 implies f of x1 less than f of x2, which shows that f of x equal to 2x plus 1 is an increasing function. Next, we can consider f of x equal to negative 3x. Let x1 less than x2. Now multiply both sides with the negative 3. See, if we multiply an inequality with negative, then it's get reversed. That inequality get reversed. Then it becomes minus 3x1 greater than minus 3x2. Now what is minus 3x1? That is f of x1. So f of x1 is greater than f of x2. See, as x1 less than x2 implies f of x1 is greater than f of x2. That means f of x is equal to minus 3x is a decreasing function. As x value increases, the y value decreases, or as the x value decreases, then the y value increases. Opposite direction. That such functions are decreasing functions. So in this way we can check the check whether a linear function is increasing or decreasing. Next, we discussed linear function. Now the linear function, its graph is a straight line. So that straight line may increasing function or decreasing function throughout in the domain. Okay, but in the case of a curve, that is functions which are not linear, such functions will be like curves. Okay, so sometime it may increase or sometime it will decrease. Okay, now the turning point define or make the whole domain into intervals. Okay, see here the turning point, this one the turning point, here also the turning point. See, at which f dash x is 0. Here this is the turning point at which f dash x is 0. Here, see. So this turning point divide the interval in the domain into intervals. Okay, so after the turning point, the function changes its nature. See, Here it is increasing in this domain. Now after this point, it is decreasing. Now after this turning point, again it is increases. Okay, so the turning point divides the function in the domain of the function into intervals. In that interval, they will the function may be increasing function or decreasing function. Okay, so at that turning point, the f dash h is 0. Okay, now theorem 1. Theorem 1. Let f be continuous on AB and differentiable on the open interval AB. Then f is increasing in AB if f dash x greater than 0 for each x belongs to AB. F is decreasing in AB if f dash x less than 0 for each x belongs to open interval AB. And f is a constant function in AB if f dash x equal to 0 for each x belongs to AB. Okay, see that f of x is defined in a given domain, and if you consider an interval in that domain, let it be AB, the interval AB, and the function is increasing in that interval if f dash x greater than 0. That is, if the derivative of the function is greater than 0 for each x belongs to AB, then the function is increasing in that interval. Same way, if f dash x is less than 0, then the function is decreasing in that interval. And if f dash x is equal to 0 for each x belongs to AB, then the function is a constant function. Now, using this theorem, we can find the intervals in which a function is increasing or decreasing. So the question may be like this: you have to show that the function is an increasing function, or function increases in this interval AB. Some intervals will be given. Otherwise, the question will be find the intervals in which the function is increasing or decreasing. So let us discuss such type of questions. Let us take f of x equal to x square minus 6x plus 4. We have to find the interval in which the function is increasing or decreasing. Okay. Now what is f dash x? F dash x is equal to 2x minus 6. Okay. Now we know the turning point means at which the f dash x will be 0. So first we have to find the turning point. For that purpose, we have to equate f dash x into 0. That is 2x minus 6 equal to 0. So 2x equal to 6. So x equal to 3. Okay. We know the function is defined for all the real numbers. Okay. So you can consider the real number line. And at x equal to 3, there is a turning point. Okay, so we can split the whole interval into, see, minus infinity to 3, one interval, then 3 to infinity, another interval. Okay, now we have to check in the first interval minus infinity 3. Okay, whether the function f dash x is greater than 0 or less than 0. Okay, so for that purpose, take any point in that interval. See, in this interval, you can take any one point at which what is the value of f dash x. So in the interval minus infinity 3, we can take 1, 2, 0 in here. number. So f dash x means 2x minus 6. Okay, what is f dash of 1? We can find 1. Replace x by 1. So 2 into 1, 2. 2 minus 6, that is minus 3. It is less than 0. You have to check for only one element. That will be satisfied for remaining all the elements in that interval. So here f dash 1 is less than 0. That means f dash x is less than 0 in the interval minus infinity 3. So we can say that the function is decreasing function, or function is decreasing in the interval minus infinity 3. Now we have to check in 3 infinity. Okay. Okay, let us take one point in that domain. Okay, in the interval 3 to infinity. See, 4 is a point in that interval. Then find f dash 4. What is f dash 4? F dash 4 means 2 into 4 minus 6, that is 8 minus 6, 2. That is greater than 0. So, in the interval 3 to infinity, f dash x is greater than 0. Implies that the function is increasing in the interval 3 to infinity. Okay. Now let us draw a table. See, how many intervals are there? 2 intervals. Minus infinity to 3, 3 to infinity. Now what about the f dash x, whether it is greater than 0 or less than 0? In minus infinity to 3, it is less than 0. Here it is greater than 0. So less than 0 means it is the function f is decreasing, and greater than 0 means the function is increasing. Okay, in this way you can conclude the result. Now, if we take the interval minus infinity 3, open interval, then we can say that it is strictly increasing in this interval. So, the function f of x is strictly increasing in the open interval minus infinity, strictly decreasing in the open interval minus infinity 3, and strictly increasing in the open interval 3 infinity. Okay.